Example number 15. Suppose the total cost C of X in dollars to manufacture a quantity X of weed killer in hundreds of liters is given by the function C of X equals X cubed minus 3X squared plus 7X plus 40, where X is greater than 0. And it makes sense for X to be greater than 0 because these are hundreds of liters of weed killer. We want to know where this function is decreasing and where it is increasing. So we start with the derivative, C prime of X, and we get 3X squared using the power rule minus 6X plus 7. Now normally when we have a square we would factor, but this time if you look at this, A times C is 21 and B is negative 6. And B is negative 6, and because of that, we're going to quickly find out that there are no two numbers that multiply for positive 21 that also add up to negative 6. Now, we could try to see if there are any by looking at a negative times a negative, right? That will give me 21, but that doesn't add to negative 6. A negative 3 and a negative 7. That will give me positive 21, but it doesn't add to negative 6. Negative 7 times negative 3, well, that's the same as the last one, which doesn't add to negative 6. And then the last pair of factors, negative 21 and negative 1, also will not add to negative 6. So this quadratic equation cannot be factored. Now we do have an alternative to factoring when a quadratic equation doesn't factor. And that alternative is the quadratic formula. So let's take a look at this quadratic formula to see what's happening. If you'll recall, X is the opposite of B plus and minus the square root of B squared minus 4 times A times C. All of that has to be divided by twice A, where A is going to be 3 and B is going to be negative 6 and C is positive 7. So plugging into our formula, the opposite of B would be 6 plus and minus the square root of B squared, negative 6 squared, minus 4 times A, 3, times C, 7. All of that divided by 2 times 3. So we get 6 plus and minus the square root of 36 minus 12 times 7, 84 over 6. So that's 6 plus and minus the square root. This is a negative. We can't have the square root of a negative. Right? Now we could go farther and find the imaginary roots, but imaginary roots have nothing to do with real world. So there are no critical numbers for this function. We know we start at 0 because it doesn't make sense to have negative weed killer. And we can pick any number to the right of 0 to do our test. So I'll just pick a 5. So in my derivative, C prime of 5 is 3 times 5 squared minus 6 times 5 plus 7 is 3 times 25 minus 30 plus 7 is 75 minus 30 plus 7. 45 plus 7 is 52 a positive number? So everything over here is positive, so this function is always increasing because the derivative says it's positive, so the slope of the tangent is always going uphill. So we say the function is never decreasing, but it is increasing on its domain from 0 to infinity.